We're going to talk about cubics and higher polynomial functions, including intercepts, factored form, which looks like this. We've done some of that before. We're going to start with an equation and get it to factored form. And then really we're going to be analyzing graphs and intercepts to get us to that factored form. So first of all, let's talk about some intercepts. So I'm just going to give us let's do like this guy here. So I'm just going to give us an example of some function f of x. So I've got my f of x axis and my x axis. These intercepts are here. So these are my x-intercepts. These are also called roots or zeros. The y-intercept, so there's only one of them, otherwise it wouldn't be a function. So there's one y-intercept there. The y-intercept is found by letting x equal 0. So we're going to let x equal 0. Let's back up also to the x-intercepts. Those are found by letting, just the opposite, by letting y equal 0. In this first example, we have not x and y, but we have a and r. We notice that a is our input, so we can think of this like the x. It would be along the horizontal axis, and r would be similar to the y. So if I were to create an axis for this, I'd have my a axis and my r axis. We want to find the a-intercepts. To find the a-intercepts, we're going to let r equal 0. So that gives me 0 equals a minus 3, a plus 5, and a minus 2. Now these are all multiplied together. So if any of these factors was equal to 0, I would have an intercept. So a minus 3 equals 0, a equals 3. I can do that to all of these, and really I can just say, what makes a plus 5 0? Well, that would be if a equals 5, just changing the signs. What makes a minus 2 0? That would be if a was equal to 2. So my a-intercepts, if I'm expressing them as points, the a would be the first coordinate and 0 is the second coordinate. So 3, 0, -5, 0, and 2, 0. And again, we can see how those come from each of the factors, just changing that sign. Next, we want to find the r-intercept. There's only one, otherwise it wouldn't be a function. So there's only one. So to find the r-intercept, we're going to let a equal 0. So as we let a equal 0, r is equal to 0 minus 3, 0 plus 5, 0 minus 2. And if I multiply that together, it's -3 times 5 times -2. -3 times 5 is -15 times -2. That's going to give me 30. So a, my first coordinate, is 0. The second coordinate, r, is 30. So there's my answer there. You could also graph that to come up with those points off of the graph. And we're going to go ahead and do that with these next ones. So here we're given a cubic. Actually, this is a quartic, isn't it? Because it's degree 4. So for this function, we want to find the c-intercept and we want to find the q-intercept. I'm going to go ahead and put this into Desmos, and we're going to look for our intercepts there. Okay, so Desmos, and I'm going to go ahead and open this up and then put both of them on the screen so we can see both the graph and the function together. Okay, so over here, not that one. So over here in Desmos, let me just clear what we had. And I'm going to start fresh. So for this one, it's c of q. Make that capital C. Doesn't really matter. Equals 2q to the 4th plus 20q cubed plus 42q squared. Now I know that I'm looking for at most 4 zeros. So let's take a look at what we've got here. Looks like I can see 3 of them. I'm just going to use my 2 fingers to pinch a little bit more, and then I can see that fourth one. And it goes down pretty far, doesn't it? So let's just, I'm going to get just a decent view. It's not going to be perfect, but let's go like from negative 15 to 15. And let's see what we can do here. So for the x-axis, I'll go negative 15 to 15. I just clicked on that wrench so that I can change these. And then I can see that negative 40 isn't quite enough. If I go negative 100, not 4100, how about 100? I can see it's not quite enough. How about 200? Oh my gosh. I'm just looking in the lower corner. 300? 500? Okay, that one does it. Geesh. And then we'll go up to 100 here. You don't have to do all of this work. I just wanted to give us a decent view. Okay, and here it is. Let me just move this around a little bit. Okay, like I said, you don't have to do all this work, but I know that I needed to do a little bit of work because it's degree 4, and I'm looking for 4 zeros. So I have a 0 here, negative 7, 0. I've got one here, negative 3, 0. And I've got one here at 0, 0. And I can see that that's also my y-intercept. It only touches the y or the c axis here at 0. So let me just make this a little bit smaller and go back over to my worksheet. So on my worksheet, my function looks kind of like this. So it goes down and then up like this. Okay, let me go to my yellow pen. If I look at what's happening at each of these zeros, I can see that right here, it looks linear. Right here, it also looks linear. These were our zeros of negative 7 and negative 3. So as I start to list my zeros, I have zeros of negative 7, negative 3. Both of these look linear as the graph passes through those zeros. So negative 7, negative 3. If I look at that next 0, which is the origin, 0 is an x-intercept, it looks quadratic there. Because it looks quadratic, we say that that guy has multiplicity 2. Multiplicity 2 would be the degree of a quadratic. So I'm going to go ahead and list this last one, comma 0. This one looks quadratic, like a parabola. So we say it has multiplicity 2. So let's go ahead and put all of this together. The zeros are the q-intercepts. So I've got negative 3, negative 7, and 0. And in parentheses, I'm going to put m2, multiplicity 2. That way I know that I've checked off 1, 2, 3, 4 zeros. I also want that c-intercept. Well, because I passed through the origin, the c-intercept is 0. I want to express that as a point. So 0, comma 0 is my c-intercept. Okay, so also on the worksheet here, whoops. Even though it didn't ask me to, let's go ahead and express this in factored form. That's going to lead us just really nicely into the next thing that we want to do. Let me just get rid of that last stray mark. Okay, so the next thing that we want to do is to be able to put this into factored form. Let's go ahead and do that. I'm going to go ahead and take my zeros. Each of them gets a factor. So I have x, let's see, to get to a minus 7, I would need plus 7. To get to a minus 3, I would need plus 3. And to get to 0, it would just be like minus 0. This one had multiplicity 2, so I put that 2 there. So multiplicity 2 because it looks quadratic, so I put the 2 there. So I'm getting myself to factored form. If I were to multiply all these x's together, though, my lead coefficient would be 1. And I take a look here, and my lead coefficient is 2. So I want to just do one more thing, and that's to put a 2 out in front. Now let's go ahead and put this in terms of our variables. So this would be c of q. Here I've got it written just generically as y, but this is really c of q equals 2 q plus 7, q plus 3. I'm just using those zeros, q squared, to come up with my factored form. Where'd Desmos go? I've got two of them open. Is it this one? No, not that one. It is the other one, of course. Okay, so here it is. Let's put this in and make sure I've got the same graph. So here I've got C, actually let's just name it Y equals, let's do 2 parentheses, and then I had Q plus 7, Q plus 3, and then Q to the second power. I don't really need that power 2. I mean, do I don't really need the parentheses? I do need the power 2. To make sure that this really is right on top of it, I can go ahead and click on and off of this color, and I can see that it's drawing right on top, so I know I've got the correct factored form. Okay, so really great segue into the next section. So let's go back to our worksheet. Okay, so I want to find some solutions and express in factored form. So for this first one, I'm actually just so it works out nice. No, let's just leave it. So for this first one, it's going to be a little bit messy, but that's okay. We can do messy math. Let's go ahead and put this one into Desmos. I am not going to work with the algebra at all for this one because I know that Desmos can give me, there we go. Desmos can give me factored form. I have 0 equals, but I want to put this in as a function. So y equals x cubed. This one's a cubic, so I'm expecting 3 zeros, minus 5x squared plus 18. Okay, so do you see what this is over here? So it looks like I've got, here we go. So I do see that I have 3 zeros. So I've got one right here, and one right here. It took a little zooming to be able to find all 3. It looked like I was going to have multiplicity 2, but I didn't. So Desmos is really nice. I'm just using my 2 fingers and then pinching and expanding to do that. You can also use the zoom in and the zoom out features. So where are my zeros? I've got one here at negative 1.6, 3, and 3.6. So let's minimize this guy and go ahead and write those zeros in. So my zeros were at, can I give myself a little more room? Okay, so they were at negative, was this 1.6? Yes, negative 1.6. So negative 1.6, I'm just rounding that guy. This one was 3, comma 3. And then that last one was, I'll just write that as 3.6, comma 3.6. Now I can express this in factored form. To get this into factored form, it would be each of these zeros is going to have a x. So it'd be x minus the 0, so x minus negative 1.6, or you can just change the sign, x plus 1.6. And then x minus 3. And then the last one would be x minus 3.6. And again, I can just do x minus 3.6. If I were to multiply these x's together, I get x cubed, and that is my lead coefficient. So that tells me that this right here, I'll put a box around it, is my factored form. Okay, really, really nice to be able to factor it, even with those decimals and everything. We would not have been able to do that using just algebra. Let's go ahead and do our next one. So our next one, I'm just going to type over what I've got. So I've got y equals x to the 5th plus x to the 4th, whoops, minus 16 x cubed plus 20 x squared, and then that's it. So let's get rid of this last term. And this should be a plus. Okay, let's take a look at this guy. This is degree 5, so I'm expecting at most 5 zeros. So I have a 0 here, and I've got one here. These are both multiplicity 2, so I know there's got to be another 0 somewhere. So it's got to cross the x-axis one more time. Let's see if I can just kind of manipulate this guy a little bit. Ah, there it is. Let me change the color so you can see that a little bit better. Let's see. There we go. Let's do it in red. Okay. So now I've got all 5 of my zeros. I knew that I needed to work on it a little bit. A good thing to do too is just to go to the settings here and just change these to -10 to 10. That's another really good way just to sort of get yourself a starting place. Okay, but I knew I was looking for 5. I've got 2 here because I see that quadratic shape. So multiplicity 2 at 0, multiplicity 2 at 2, and it goes right through there just as a straight line. So just multiplicity 1, or we've got a single one there at -5. So let's transfer this over to the worksheet. I'm just going to give myself just a little sketch here of what this would look like. Kind of like that. Okay, so I've got a 0 at, and I can go ahead and just hover over to get these at -5. This one's at 0, and the next one is at 2. If I go ahead and I look at my behavior as I'm passing through these zeros, I see that that one is linear, so there's no multiplicity there. This one looks like a quadratic, as does the one at 2. So those are both going to have multiplicity 2, degree 2. Let's go ahead and put this together in factored form, and then I'll put those zeros back in there. So in factored form, I need to get to a -5, so that's going to be x plus 5. I need to get to a 0, so that's going to be x minus 0, which I can simplify. That guy looked quadratic, so it's degree 2. And then I've got 2, so x minus 2, also degree 2. So if I were to multiply these together, this is x, that would be an x squared, that would be an x squared, and that gets me to degree 5. The lead coefficient is 1, so I'm good to go here. I can clean it up just a tiny bit. X plus 5, x squared, x minus 2 squared, and this was f of x equals. Okay, let's also put those zeros up there. So the zeros are -5, comma, 0. This one had multiplicity 2, and 2, multiplicity 2, just telling me that it looked quadratic. And also this tells me that I've got 1 0 here, 2 zeros here, 2 more zeros here for the total of 5 zeros. And that matches my 5th degree polynomial. Okay, so again, knowing all of these pieces allow you to find that factored form and all of the zeros. Okay, this one says find the roots. Roots are also x-intercepts or solutions when we set this equal to 0. But if I'm doing this in Desmos, I want to put it in as a function. So I'm going to go ahead and put in the y equals. Let's go ahead and clear what we had. And I'm just going to start this one from scratch. So y equals 2x squared minus 4x minus 30. I'm looking for 2 zeros because of the degree of my polynomial, and I find them. I don't need to do any more work with zooming. I find both of them right there. Notice how it goes through those zeros linearly, so it looks like a straight line, so no multiplicity either. So this one's really pretty straightforward. So I have a 0 at -3, and I have a 0 at 5. Let's put those in there. Move out of my way. Actually, I've got room, right? So -3, there we go, and then 5. If I put it into factored form, we would say that y equals, I have an x minus -3 and an x minus 5. If I multiplied the x's together, I would get just x squared, but I see that I've got a lead coefficient there of 2. So I need to go ahead and put in a 2 on the outside. If I rewrite this one, just cleaning it up a tiny bit, I get 2x plus 3, x minus 5. And we can check to make sure that we've got the right factored form by just typing that one in as a second function. So y equals 2, parentheses, x plus 3, x minus 5. Gosh, perfect. So I can click on and off of that color to make sure it's right on top of my other graph. Okay, excellent. So I've got factored form here. I'll put that in the box. And my zeros. Okay, next, finding factored form from a graph or function behavior. So for this one, I'm given the graph, and I can go ahead and look at the behavior and make sure I get the right equation. We'll also be checking this in Desmos. I can see my zeros. Grab a different color pen. So I've got a 0 here at 3. I've got a 0 at -2 and a 0 at 1. So my zeros are -3, -2, and 1. Already, I've got a bunch of really great information. I can put this into factored form. That would be an x plus 3. I change the sign, x plus 2, and x minus 1. I'm going to check for multiplicity, but I do notice that this is a cubic. And it looks like a cubic that has not been reflected, and I can tell that by my end behavior here. But we can also check and see the behavior at the zeros. It's passing through each of those zeros linearly. So there's no multiplicity here. They're all to the first degree. The other thing that I would want to check is to see, is maybe there a possibility of an A out here in front? I could check for that with a point. Before I do though, let's go ahead and see if this is good enough. I know there's no reflection, and I can see there that I've got that point there at -6. I'm going to put this guy in. Let's see, it's an h of t. Let's go ahead and put this in as our guess. So h of t, we're thinking it's going to be t plus 3, t plus 2, t minus 1. The only thing we can't tell is if there might be some kind of a stretch or compression. Okay, let's get rid of both of these. And then this is going to be h of t equals, parentheses, t plus 3, t plus 2, t minus 1. And I want to see if it goes through that point here. Does it go through the point? This is how I'm going to double check, of -6. So that'd be 0, -6. Let's go ahead and check. I click on the graph there, and I see it does. There it is. So it does go through at -6. So there's no stretch or compression here. The other way that I can double check this is to go back to my worksheet and change the x and y mins to match these. They're going from -5 to 3. Let's go ahead and grab my wrench here. So on the x-axis, they're going from -5 to 3. On the y, which would be the t-axis, it looks like they're going from -7 to 3. Now I can take a look and make sure that it matches the graph I was given. This is a really nice way to do it. And there you can see it looks like the graph that we started with. Okay, excellent. So that is my answer. So I'm not going to rewrite this one. I'm just going to put an arrow, and that goes right there. Okay, number 2. So for number 2, this one also looks cubic to me. So it looks cubic, but a cubic in its original form would have looked like this. So I can see that I've got a reflected cubic. So I'm looking for at most 3 zeros. Let's go ahead and find those zeros. So I've got one here at -3. I've got another one here at 5. That's only 2 of them, but I do have multiplicity. As I go through -3, I go through it quadratic, or in a quadratic manner. Okay, so that would be multiplicity 2. That's supposed to be an m. But as I go through the 0, 5, I go through it linearly, so that'd be degree 1. Let's go ahead and put this one together. So as I'm just starting to put this guy together, it's going to look like x plus 3. That one had multiplicity 2. Again, that's an m. Multiplicity 2. But for the 5, there was not a multiplicity, so x minus 5. What I don't have, though, is the reflection. If I multiplied my x's together, I would end up with just x cubed, and it would be positive. But I know that there's at least a reflection in here. So I'm going to go ahead and put a in here. Let's just try the negative before we pick a point and solve for anything. So I'm going to go ahead and try f of x equals, let's just try it with a negative first, x plus 3 squared x minus 5. And if that works, that's great. We don't need to do any more algebra to find this. Okay, so this one's going to be f of x equals negative out in front for the reflection, x plus 3. That one had multiplicity 2. And then x minus 5. Okay, so let's also change, while we're here, let's also change our viewing window because it's radically different, at least in the y-axis. So in the x-axis, it goes from -6 to 6. But for the y-axis, it goes from -40 to 160. Okay, big difference. So it's looking pretty good, isn't it? But I noticed that I've got a point. It goes through the y-axis between 80 and 100. And here it's going through the y-axis at 45. And moreover, I've got this relative max there at 75. But here my relative max is above 140. So there is a multiplier. So we do need to do just a little bit of math. Whoops, let's make this guy big. So I was really close, but I do need to do the math. So it's worth it just to try. Let's go ahead and erase what we've got here. And I'm going to go ahead and set this up so that I'm ready to do the math. I'll go ahead and do a blue one. So we're going to use y equals a x plus 3, just putting my template back together, x minus 5. We need a point. And I'm just looking for a nice point, and I find it right here. So that nice point is at 4, 100. So my point is going to be 4, 100. So x is 4, y is 100. Let's go ahead and put that into our function. So 100 equals, we're solving for a. I know it's going to be negative, but it's going to be a stretch as well. 4 plus 3 squared, 4 minus 5. So 100 equals a. 7 squared is 49. 4 minus 5 is 1. So if I divide both sides by 49, a is 149ths. We would never have guessed that one. So 149ths is going to go in here. And it's going to be negative as well. Oh, here's where I lost my negative sign. 4 minus 5 is -1. Negative. Okay, hopefully you caught that as well. So minus 149ths, x plus 3 squared, x minus 5. Let's check this now in Desmos. So if I switch over to Desmos, I'm going to change this to -149ths. So I'm just going to put type a slash so I get my fraction, 149ths in the denominator. Okay, so it's looking good. I can check and make sure that this point 4, 100 is in my function. If this is in my function, f of 4 is my x, should match me to 100. So let's do that in Desmos. Really great way to check. Just going to grab an empty cell there and do f of 4, and sure enough, it's 100. So I know I've got the correct function. So this right here is my answer. So for this one, I had to use a combination of the graph, looking for those zeros, but then I also did that algebra, and we've done this before. If we want to find that value a, we find a point, plug in x and y, and then solve for a. Okay, so we've got, I believe, just one more here in this group. Okay, so one more here in this group. For this one, we have, let me mark these. So we've got a 0 of -3. Those look linear, right? A 0 at -2. So far we've got, that would be x plus 3. No multiplicity there, x plus 2. I've got 1 at 1. This one has multiplicity 2, though. So that's going to be x minus 1 squared. And then finally 1 at 3. So x minus 3. Let's see. This has also a nice point that I can use to test to see if there's any kind of a stretch or reflection. Those are my only zeros, so I can put arrows here and here. This is what a degree 5 would look like. So degree 5 can do just a bunch of stuff in the middle, right? But then I've got to come back up and it looks kind of cubic at the ends. So I know that this is right for a degree 5 with no reflection. What I want to do first, let me just erase that. What I want to do first is to type this in just to see. So maybe I'm there. And if I get this point, so let's see, this would be the point 0, -4. So that would tell me that f of 0 would equal -4. Or in this case, y of 0 would equal -4. Let's go ahead and put this guess into Desmos. I'm going to clear what I had. Gosh, isn't Desmos nice? And let's go ahead and type this guy in. So y of x equals x plus 3, x plus 3, x plus 2, x minus 1 squared, and then x minus 5. I'm also going to change my viewing window. So let's go to the wrench here. It goes from -5 to 5. I didn't really need to change the x's. They're pretty darn close. But the y's are very different. They go from -6 to 6. -6 to 6. And I'm looking for an intercept at, it doesn't look like I have it. Did I miss one of my zeros? Let's check. Dun, 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 make that bigger. Nope, I've got them all in there. So I was expecting an intercept here at -4, and I don't have an intercept at -4. So I do need to go ahead and put that point in. So instead of a stretch, it looks like this guy's going to be a compression. You can also check it here. Y of 0. Oh, let's actually, it doesn't like y of, does it? Let's just change this to f of. And then I'll bet it will let me do f of 0. There we go. -30. That's not what I wanted. I wanted f of 0 to be -4, right? -4. Okay, darn. So we have to do the math, but that's okay. It's not too difficult because of this nice point that we found. So I do need to put that value a in. Y equals, and I'm going to go through that process where we find a known point, 0, -4, and we're going to plug that in for x and for y. Okay, so y equals, y is -4, so -4 equals 0 for all those x's, super nice, 0 plus 3, 0 plus 2, 0 minus 1 squared, 0 minus 5. Okay, so -4 equals a times 3 times 2. -1 squared is 1. Okay, I can do this. -5. Let's see. So that's going to be -10 times 3, -30. -30a is -4. So if I divide by 30, again, we would never have guessed this. I can reduce this by 2, divided by -30. What do I get? 2/15? Again, would never have guessed 2/15. So this guy should be 2/15. So it looks like our answer is going to be 2/15, x plus 3, x plus 2, x minus 1 squared, x minus 5. If you can do this one, you can do any of them. Let's put that 2/15 right in front. I'm just going to put my slash to get a fraction, and then 2 over 15. Now, and I can see it on my graph right here. And take a look at my next line. F of 0 is -4. Okay, perfect. So I work with the zeros first, find my template, and then decide if I need to get a value a out in front as a multiplier, and we grab a nice point to do that. Okay, next section. Next, we're going to work on finding the formula given some information about the graph. Okay, so we've got degree 5, a lead coefficient of 1, roots of multiplicity 2, so both of these have multiplicity 2. So if I put those together, and a root of multiplicity 1 at -5. So let's go ahead and put this together. That lead coefficient of 1, the lead coefficient is a. So I can start to put this together with just a 1 out in front, or you can just leave that blank. So that's really nice information. Roots of multiplicity 2 at 0, so that's going to be x minus 0 squared, x minus 2 squared, and multiplicity 1 at -5, x minus -5. Let's go ahead and clean this up, and it's going to be y, or f of x. I can drop that 1, x squared, x minus 2 squared, x minus, plus 5. There we go. Okay. Oh, easy. Next, oh, and let's check the degree. I didn't check that. So my degree, I want to just show you how to run through and check that degree. I'm going to take each of my powers, and I can sneak a power 1 in there. So it's going to be each of my multiplicities or powers. 2 plus 2 plus 1 equals 5, and that matches my degree. Okay, just forgot that one last check. Okay, part B. This time we're not given the value a. Instead, we're given that point. And remember, we can use those, whoops, just labeled it backwards. Instead, we can use the point x comma y. Remember, we use that to find our value a. Okay, degree 4. So a root of multiplicity 2 at x equals 2, multiplicity 2. So we don't know what a is. Put a there. 2, so x minus 2. 2 is a root. Multiplicity 2. Multiplicity 1, so these don't have a degree other than 1. That's going to be x minus 0, and then x minus -1. So we get y equals a, x minus 2 squared, x plus 1. Let's go ahead and check our degree before we do the extra work of finding the value a. So I've got 2 here. These would be 1. So my degree is 2 plus 1 plus 1, which equals 4. Perfect. Okay, so I've got the degree equals 4. Check. Let's go ahead and do this next part. So I've got this point. So now we're going to find a. So we're going to use x comma y equals 5 comma 162 to find a. Okay, so we've used that process before. Let me go back to my blue pen. It's just easier to read. So we have y, which is 162, is equal to, we're solving for a, and now let's put our 5 in. 5 minus 2 squared, 5 plus 1. Okay, so this is going to be 162. 5 minus 2 is 3. 3 squared is 9 times 5 times 6. I'm going to cheat. Be efficient. So what do we get? So we want to do 9 times 5 times 6. Enter. 270. Okay, I'm glad I did that with the calculator. So 162 equals 270a. Divide both sides by 270. And I'm going to, again, let my calculator do this division. It will reduce that fraction for me. Yay, calculator. Okay, so 162 divided by 270. And I know I want a fraction, so I'm just going to do math. Choose number 1 by entering, convert to fraction, and it's 3/5. Okay, thank you, calculator. So a is 3/5. Let's go ahead and put this all together. I'm going to write it in green so you can see it. So my function from here, now that I've got a, y equals 3/5 x minus 2 squared x plus 1. How could you check this to make sure it's the right answer? Well, you can check it the same way we did with the graphs. I'm going to go ahead and plug this in to Desmos. I'm going to do it like an f of x. And with this point right here, it had better tell me that f of 5 equals 162. Okay, now I'm really hoping I did my math right. Moment of truth here. Let's clear these. and type our function in. So f of x equals, I need a fraction, and that's 3/5. And then I get x minus 2. That one had multiplicity 2. And then x, and then x plus 1. Okay, so we should see, here's 5 over here. Let me make it big. Okay, 5 is like way over here, right? Whoops. Okay, so here's 5 over here. So it's going to be, way up there somewhere. So far, so good. So let's do f of 5. Yay, 162. Okay, I was a little worried there, to be honest. Okay, so I'm feeling really good about this because I was able to confirm that this point is in fact on my graph. So I'm feeling really good about this answer here. That's a little bit of a mess. There's my answer right there.